Good afternoon. We're the Solar Engineering Research Racing Team, and this is what we did this semester.
My name is Adrian Cartagena, leader of the weighting division, and I will be presenting the progress of my division this semester. Semester objective is VDR resubmission and regulations, implementation of SERRT and kill switch circuits, work with motor controller swap, and work with the manufacturing process. In VDR resubmission and regulations, we work with the VDR in which we obtain a yellow color, but we are waiting to obtain the green color with the resubmission. Some of the changes that were made were the electrical diagrams and adding BBS information. In start and kill switch circuits, the emergency turn-off circuits kill switch was successfully made in order to turn off the entire vehicle in a single switch and turn it off in a button outside the vehicle. High voltage relay controlled with another relay were used to invert the normally open of the high voltage relay to normally closed. In motor control swap, the old motor was repaired. We created the diagram to interface the electric motors with the waste sculpture controller. This was done in order to make use of the Mitsubishi motor with the waste sculpture controller and improve its performance parameters. However, it was not possible to program it due to the lack of information, but it was possible to make a huge advance in this process. As part of the manufacturing process, it was possible to place some of the solar panels on the vehicle cover. It was sanded and placed with the same glue that the solar panels have. Also, some shopping lists were made for the manufacturing process, as well as receiving donation of material for this process. For future objectives, we will be working with the implementing the where sculpture control to both motors and program them. Where the new vehicle test the solar panel with the MPPTs and work with the implementation of the dashboard, its diagnostics and energy management system.
Hello, my name is Kiara Perez, and I'm going to be presenting everything that battery worked through the semester. The semester objectives were submit the vehicle design report, manufacture a new battery module, design and manufacture a battery box, and fix the voltage tap connections. The main focus of the division was submitting the VDR documentation to comply with the competition regulations. The division performed research and documented important information about the battery and its components. And in February, the VDR was sent, and shortly after, the division received the news that the documents passed the evaluation. As a backup for the competition, the division wanted to manufacture a new battery module. As the division awaits for the new battery cells, members have been practicing their soldering skills. To store the battery, a new battery box was designed, and this design was put through a thermal analysis test that passed easily. The new battery box is being manufactured as we speak, and the materials used are divan cell and fiberglass. The original voltage tap connections of the battery were loose and not reliable, and to assess the problem, the division changed the voltage tap connections and performed cable management. And the voltage tap connections were tested, and they showed that they were successfully installed. For future objectives, the battery division has finished manufacturing the battery box, manufacture and test the new battery module, and finally test the battery with the car.
Hello, my name is Gabriel Roman. I am the telemetry division leader, and today I'm going to talk about the stuff that we did this semester. For this semester, we resolved the pending speed data retrieval issue. We had extensive testing of various solutions to the speed data retrieval issue. We also had the full setup and configuration of the Raspberry Pi 5 and successfully tried to implement the speed data retrieval solution. For the speed data retrieval solutions, we had an issue that the Raspberry Pi 4 pins read either high 3.3 volts or low 0 volts. Initially, our motor to Pi line worked correctly when testing on the motor itself. When assembled altogether, the voltage appeared to have a disturbance that interfered with the value, as you can see in figure 1. Our solutions to resolve the issue were a NOT gate circuit that is shown in figure 2, a voltage divider that is showed in figure 3, read voltages from the analog and digital GPIO pins of the microcontrollers such as the Arduino Uno, Arduino Mega, and ESP32 as shown on figures 4, 5, and 6, and utilizing the onboard Hall effect sensor that the ESP32 provided, which you can see there in figure 6, and finally a standalone Hall effect sensor component. For the Hall effect sensor component circuit, we used a Hall effect sensor component that was available in the workshop, and we modified the existing code and circuit to manage the better results. The motor has 32 inductors, 16 positive and 16 negative, that these will trigger the Hall effect sensor component. The advantages of it are the Hall effect sensor component has a much wider range and can be placed safely in range and reduces greatly the possibility of damages. As you can see here, we are testing the Hall effect sensor with magnets, showing the changes in polarities. There you can see the Hall sensor script. The way the Hall sensors work is by measuring the changing voltage when the device is placed in a magnetic field. The code's primary function is detecting 16 polarity switches from the motor's inductors. 16 is a rotation. After identifying the polarity switches, we record the time to identify the speed in which the vehicle will be traveling. For the future objectives, we have to connect the Hall effect sensor to the Raspberry Pi, successfully implement the speed data retrieval solution to the Raspberry Pi 5 ecosystem, connect the battery BMS via CAN bus, and recruit new members.
My name is Luriana Roy Ortiz, and I'm the leader for structure design, and I'll be presenting what we did this semester. For the semester objectives, we have to improve the chassis design, rerun chassis static impact analysis, finish chassis manufacturing, design the suspension, complete suspension system analysis, design the braking system, and design the steering system. We did design improvement, minimize the amount of tubes of complexity of the design while maintaining the same material, aluminum 6061. The static impact analysis passed with a design improvement with a minimum of 1.2 and a maximum of 2.4 safety factor, and we also did analysis for the front suspension support, and that passed with a safety factor of 4 and the rear suspension support with a safety factor of 8. Here you can see the analysis done to the chassis impact, and here you can see the chassis suspension support. Here you can see the beginning of the chassis manufacturing and how it is now. And then you can see the old design, and now you can see the new and more improved design. The suspension, for the front suspension, you can see we did a bicycle fork style fork, and it has in one side the spring, and then on the other side it has the caliper. And for the back rear suspension, we did a single A-arm suspension, and you can see the how it would look everything together with the chassis. For the rear suspension, the analysis were done by hand calculations. We did a free body diagram, suspension bottle displacement, and K of spring. And with an Excel sheet, we calculated shear moment, inertia, deflection, bending, and safety factor. With this same approach, we did the forces for the front suspension, and then we took those forces and them in the SolidWorks, and then we did static analysis to each part, since the front suspension is a little bit more complicated, and everything passed with a 1.5 for bump forces and turning forces with a 1.8 safety factor. Also designed the braking system, and it will be a simple hydraulic braking system composed of two braking pumps, a braking pedal, braking lines, four motorcycle calipers, and a brake hose. Pedals will be positioned in front of the driver with two pumps and a plate supporting them. For future objectives, we have to pursue suspension, steering, and braking materials, complete suspension manufacturing, assemble braking and steering system, and commence testing.
Hello, my name is Diego Rivero, and I will be presenting what the aerodynamics division did for the semester. Well, the aerodynamics division was solely focused this semester with the manufacturing process and just getting the body mold done and making the top lid, along with starting the process for the canopy. First, in the semester, we started with making the top part of the lid. This was done by making ribs out of foam with the desired curvature, attaching them over the length of 12 feet, which is the length of the lid, and then covering those ribs with formica, the type of cartolina that we're using. And then on top of that, preparing it with mold release, and then starting by adding the alternating layers of fiberglass and divinycell to make the lid. Once the lid was finished, we can start with the foam molds for the bottom half of the car, starting with the fairing molds. Each fairing is a combination of 24 pieces, one bottom half, one top half, while that were given side curvatures to have the curvature desired of the fairings. Additionally, with a curvature on the top half of the fairing to add the negative curvature of the lid so it can attach completely to the bottom lid mold. The bottom lid mold was made very similarly. It's made out of 12 pieces, 6 on each side, both having more or less the same curvature since it's symmetrical on the y-axis. Each chunk is about 2 feet long. It was put through the foam CNC and given the desired curvature. Once that was done, they were glued together, adding little wooden skewers to add extra strength for the glue when the lid is moved, since it has a tendency to separate with its own weight with some bending forces. After all these molds were done, they were sanded down. Both fairings were sanded, the top half and the bottom half, after being glued together to have a flush and even surface, well, by making them the same size. The lid is also completely attached and will be sanded down to have a smooth surface. Once these two things are sanded and the surfaces are to our liking, they will be glued together using the dimensions already assigned in the CAD model to have a 100% made bottom half mold of the car. Once this is done, the entire surface will be covered in formica to prepare the surface to then have fiberglass and resin be put on top of it. For future objectives, we have finishing up the sanding and perfecting the surfaces of all the molds. We still have to cut and shape the bumpers that will go on the sides of the bottom body to add to maintain the curvature of both lids. And we also have getting the materials left for making the canopy, which is the lexang, and cutting the foam molds for the canopy to make the fiberglass half of it. Once all this is done and the chassis is put together in all three parts, the top mold, the top lid mold, the bottom mold, and the canopy, it can be completely attached to the chassis and the body will be complete.
Greetings. My name is Dario Perez. I am the leader of marketing and outreach, and I'm here to discuss what we did this semester. First, in our sponsorship division, we managed to increase our movement in Twitter, Instagram, and Facebook. As well, we recollected some content material for next semester. As well, we kept looking for potential sponsors, which we presented our new made sponsorship proposal. And for fundraising and outreach, we put ourselves the goal to recollect $4,000 for the team as for they needed to manage their necessities in materials. And we performed outreach activities such as engineering fun day and project fair. As for some are our successful sponsorships, as for monetary sponsors, we had Costco and Econo, which donated money for our costs. Then we work alongside with the structure division to renew some of the licenses that they have for SolidWorks since they expire on July, and we needed those licenses for next semester. Also, we contacted the College of Automotive and Technical Mechanics to make an inspection to our trailer, which is outside of the workspace. And finally, we contacted Enterprise to look for information of our account of Enterprise to manage to transport people in our competition. As for some fundraising events we have the original pizza sales and frappe sales, as well of our original basketball tournament. As for some new fundraisers, we have the quesadilla sales and the cake sales. And for our most successful fundraiser was the raffle sale, which funded approximately $2,000. Among the recollected money that we have, among all the sales we did, we recollected $4,134, and adding some of the few small sponsorship that were given to us, we recollected for $4,409, which exceeds our original goal by 110%. as for future objectives, we we are going to look for new sponsorship alternative. Also, we are going to watch social medias for new content ideas, such as our first thing for the next semester is meet the teams. Um, then in fundraising and outreach, we are going to determine and evaluate some of our new activities that we can make so we can generate profit, and we are going to recruit some new members.
That's it for our presentation. Thank you very much for paying attention to us.